supporting society and people's lifestyles, rail cars, industrial equipment, building facilities, electric vehicles, renewable energy such as wind and solar power generation, and various home appliances. Power devices are essential for power electronics equipment to achieve a low-carbon society. Attracting attention as the most energy efficient of these power devices is one that uses a new material, silicon carbide, or SiC. Power devices perform the role of a switch that operates at ultra-high speed, capable of turning on and off thousands to several tens of thousands of times per second. The flow of electric power can be easily controlled by fine-tuning this on-off interval. In other words, power devices enable continuous variation, and together with an inverter that converts direct current to alternating current, they play a vital role in energy savings based on the important factor of reducing power loss. Silicon is used in these power devices, but due to its characteristics, in recent years, further reductions in power loss had seemingly reached the limit, leading to the search for a new material. A candidate attracting attention as this new material is SiC, a compound that combines silicon and carbon at a ratio of 1:1. There are high expectations worldwide that, owing to its characteristics, SiC can be installed in power electronics equipment to realize much greater energy savings. Mitsubishi Electric began developing SiC technologies in the early 1990s. And we have since developed various element technologies that utilize its characteristics. In 2010, we released a room air conditioner, which became the world's first room air conditioner to be equipped with an SiC power device. Then in 2011, we commercialized an inverter using developed SiC power devices for rail cars. In 2012, our railcar inverters were installed in Tokyo Metro trains, the first time in the world for an inverter of this kind to be installed in commercially operating railcars. We were able to prove that our inverters provide significant reductions in power consumption and enhance the regenerative power ratio. For industrial equipment, we released a drive unit produced using SiC for computerized numerical controllers in December 2012. As seen here, Mitsubishi Electric has already achieved successful results in the practical application of SiC power devices in various power electronics equipment. But this is only the beginning. We will continue introducing more competitive products utilizing cutting-edge technologies. SiC has four main advantages. It reduces power loss, realizes high-speed switching operation, can be operated at high temperatures, and has excellent heat dissipation characteristics. Starting with reducing power loss, SiC has approximately 10 times the critical breakdown strength of silicon. Furthermore, the drift layer, that is a main cause of electrical resistance, is 1/10 of the thickness. This allows a large reduction in resistance value and, in turn, reduces power loss. This SiC characteristic enables dramatic reductions in conductivity loss and switching loss in power devices. The next advantage is SiC's high-speed switching operation. Its high critical breakdown strength reduces power loss and also means that it can easily handle high voltage levels. Based on these superior properties, high-speed switching operation can be achieved in device structures that place priority on operating speed. Moving on to high-temperature operation, previously, when the temperature increased, electrons moved to the conduction band and increased the leakage current. At times, this resulted in abnormal operation. However, SiC has 3 times the band gap width of silicon, preventing the flow of leakage current and enabling operation at high temperatures. A final merit is heat dissipation. SiC has 3 times the heat conductivity of silicon, which improves heat dissipation. Utilizing these 4 advantages, SiC has realized more compact cooling systems and inverters, allowing equipment to be made ever smaller, lighter, and thinner. These wondrous characteristics of SiC have led to its use in power electronics equipment. Based on successful results in practical applications and advancing development, Mitsubishi Electric produces commercial power devices that pull out SiC's maximum performance. What's more, the development burden on customers has been reduced through the provision of modules with elements such as drive circuits and protection features embedded. The benefits that can be expected as a result of installing SiC power devices in various equipment are as follows. For rail cars, we have reduced the total power consumption of rail car inverters by introducing large reductions in the power loss of power devices. Moreover, regenerative braking can be applied in all speed ranges, making it possible to increase regenerative performance. Noise is reduced, and railcar inverters that are more compact and lighter have been realized, which is expected to lead to the further improvements in railcar systems. In industry equipment as well, through the large-scale reduction of power loss in power devices, it's possible for motors installed in production machinery to have higher torque and speed. This facilitates increased productivity for machine tools. It's also possible to make machinery and cooling systems more compact based on SiC heat dissipation characteristics and the ability to operate at high temperatures. Furthermore, through the adoption of a low inductance package, power modules have become more compact, reducing installation area by approximately 60% and realizing smaller and more lightweight factory automation devices. The remarkable reductions in switching loss and recovery loss in dual inline package intelligent power modules, or DIP IPM, have enabled further energy savings in home appliance inverters. Additionally, in SiC dual inline package power factor correction devices, or DIP PFC, the size of peripheral components such as reactors and heat sinks can be reduced through high-frequency switching at a maximum of 50 kHz. It's also possible to reduce the number of peripheral components by embedding drive IC. Until now, a height adjustment spacer was used for products that share the same inverter and heatsink. But since SiC DIP PFC feature the same package as ultra-compact DIP IPM, a spacer is no longer necessary. Size reduction has also been realized by reducing the installation area and simplifying wiring patterns. SiC power devices also contribute to more compact and thinner home appliances with astonishing energy efficiency. In the field of renewable energies, power conversion efficiency has been improved within energy conversion units. Passive components are also being downsized thanks to the reduction of noise using high-frequency operation. This is expected to result in more compact power conversion units and easier to install equipment. In the case of building facilities, SiC Power Devices are expected to achieve overall energy-saving benefits for elevators by reducing power loss. Devices such as control panels have become more compact, and the smaller installation area allows increased layout freedom. And that's not all. The size of cooling systems and peripheral components in electric vehicles can be minimized, making it possible to integrate the motor and inverter sections. The result is reductions in volume and mass, making it possible to reduce overall vehicle weight. Synergistic benefits should not be discounted either. The effective use of regenerative power enables greatly enhanced energy efficiency, and it is expected that longer driving distances will be realized. SiC Power Devices have endless potential in power electronics equipment. Using Mitsubishi Electric's successful achievements to date as a springboard and applying ongoing innovative developments, we will continue to expand our product lineup of power devices, fully leveraging the superior performance of SiC. Various power electronics equipment supporting society and people's lifestyles. If SiC Power Devices were installed in all power electronics equipment, the resulting energy-saving benefits would be enormous. Mitsubishi Electric, contributing to the realization of a low-carbon society and more affluent lifestyles.